Hi everyone, this is the last video for section 6.1, going over the basics of fractions. And so in this video, we're going to talk about benchmarks. So benchmarks are, like it says, it's a standard or reference by which others can be measured or judged. So this definition is really general. It's not kind of specific to fractions, but when we make it specific to fractions, right, we're talking about specifically the ordering of fractions. So our benchmarks are going to be numbers on our number line. Let me write this down. So numbers on the number line commonly used to order others. Commonly used to order other numbers. So numbers like this are 0, 1, 1/2, and we also typically use 1/3, 1/4, 1/5, and so on. So these are just kind of common benchmarks. So benchmarks, this isn't like a fixed list. These are just the most common ones we use. We kind of compare how close numbers are to 0, how close numbers are to 1, how close they are to 1/2, just because those are kind of easy to see. These are easy values to see how other numbers compare to them. In the last video, we talked about how close and how far away these numbers were from 1, because that's an easy thing to judge. So in that case, we used 1 as our benchmark. So up here, we used 1 as our benchmark. Okay, so now we're just going to talk about benchmarks generally. So I think the best way to kind of see how this works is just by doing examples. There's examples in the book, but we're going to do some here as well. Use the benchmarks to order these from least to greatest. Okay, so let's just start with using 0. So which one is closest to 0? So the one that's closest to 0, 9/10 is not, it's really close to 1, 7/15 kind of in the middle, 5/8 is kind of in the middle. So the closest to 0 is going to be 1/17. And so that means that this is the smallest value. Okay, so then we're going to look at closest to 1. So we're left with, once we kind of use 1/17, we can cross it off. So the closest to 1, now we're looking at 9/10, which is really close to 1, 7/15, kind of in the middle, and 5/8 kind of in the middle. So the closest to 1 is 9/10. So this is going to be our largest number, and we can cross it off our list. Okay, so now we've said kind of audibly that 7/15 is kind of in the middle and 5/8 is kind of in the middle. And what I mean by middle is these are both kind of close to 1/2, because half of 15 is 7.5 and half of 8 is 4, and 7 and 5 are respectively each close to those values. So what I want to do is I want to start comparing 7/15 and 5/8 to 1/2. So 7/15. So like we just said, half of 15 is 7.5. So this is slightly less than 1/2, right? We don't get quite half of 15 when we're at 7. And when we look at 5/8, so we know that 4/8 is 8, or 4 is half of 8. So that means that 5/8 is a little bit bigger than 1/2. And this is all we need. All we need to know is which one's closest to 0, which one's closest to 1, and how 7/15 and 5/8 compare to 1/2. And then we can order them. So our order is going to be 1/17 is the smallest, 7/15 because it's less than 1/2, 5/8 because it's bigger than 1/2, and then 9/10 being closest to 1. So this is going to be our order. And explaining our reasoning, this is all the work that we need to show. Closest to 0, closest to 1, and then comparing these two numbers to 1/2 is all the work that you need to show. But I want to make a number line just to kind of illustrate more so how this works. Well, I guess I didn't need it to be that large. Okay, so if 0 is here, 1/2 is here. Oh no, okay. 1/2 is here. And 1 is here. Okay, so how are we building our numbers on the number line? Well, we said 1/17 is roughly over here. It's pretty close to 0. And similarly, 9/10 is pretty close to 1 over here. But then the reason we compare numbers to 1/2 is we know that 7/15 is on this side. And, oh, that is not true. Okay. So we know that 5/8 is on this side, being bigger than 1/2, and 7/15 is on this side, being less than 1/2. So whenever we first talked about kind of these orderings, we know that you can put a less than symbol in between all of these numbers on the number line, and then that's how we get our order. So essentially, using these benchmarks just kind of, it's telling us where these numbers fall on the number line, and then we can order them like so. Okay, so we're going to do another example of this. Okay, so we're going to do it in the exact same way. So we're going to look at what's closest to 0, and then closest to 1, and then go from there. Okay, so the closest to 0, we have 2/7, which is pretty small, 1/9, which is also pretty small, 21/22, which is close to 1, and then 5/11, which is close to 1/2. So in this case, we need to compare 2/7 and 1/9. So which one's going to be the closest to 0? So you may have some intuition about this. But if you don't, we can just cross multiply. So 2/7 and 1/9. 1/9. If we cross multiply, well, we want to know which one's bigger and which one's smaller. So I think the easiest way to probably do this is to get a common denominator. And that can essentially be done by cross multiplying. So we'll just get a common denominator to compare these. So 2/7 times 9/9 is 18/7 times 9, which again, we don't really care what it is because it's going to be the denominator for both of these. And 1/9 times 7/7 is going to just be 7/7 times 9. So in this case, clearly 2/7 is bigger because the numerator is 18 compared to the numerator of 7. So that means that 1/9 is smallest because it's the closest to 0. Okay, so again, we'll do closest to 1. So we've already done 1/9, already placed it. So now closest to 1, well, 2/7 we know is small. And 21/22 is pretty big, it's pretty close to 1. And 5/11 is close to 1/2. So the closest to 1 is 21/22. Okay, so now we need to compare 2/7 and 5/11. So like we did before, we can start by comparing these to 1/2. Okay, so 2/7. Well, 1/2 of 7 is 3.5, and so 2 is less than that. So this is less than 1/2. And 5/11, well, 1/2 of 11 is 5.5. So this is actually, again, less than 1/2. So if we were drawing a number line, like I did before, that had 0, 1/2, and 1. We've already placed 1/9 here. And we can place 21/22 there. And so now we're trying to place 2 sevenths and 5 elevenths, and they're both somewhere in there, right? Less than a half. So we're going to need another benchmark to compare them. Okay, so if we look back at our list of common benchmarks, well, we had 0, 1, 1/2, but then also all of these fractions that had 1 on top, 1/3, 1/4, 1/5, and so on. So now let's compare them to 1/3. So 2 over 7, and we want to compare it to 1/3. So this is going to be kind of hard to compare this to 1/3. So let's convert 1/3 into something that has a 2 on top. So 1/3 is 2 over 6. And we want to now compare that to 2 over 7. So using what we talked about before, if two numbers have the same numerator but different denominators, the one with the larger denominator is smaller. Okay? So now we have that 2 sevenths is bigger than 1/3. So if we put 1/3 on our number line, we know that 2 over 7 is somewhere greater than 1/3 but less than 1/2. Okay? And now we can also compare 5 over 11. So we can convert 1/3 into something with a 5 on top, which is 5 over 15. And we want to compare that to 5 over 11. So again, the thing with the larger denominator is smaller. So 5 over 11. Oh, shoot. I'm sorry. This 2 sevenths was supposed to be smaller than 1/3. So 2 sevenths goes here. So 2 sevenths goes here. And then 5 over 11 is bigger than 1/3 but less than 1/2. So that goes there. Okay, so now we have our number line and we can write the order of our numbers. So the order is 1 over 9, 2 over 7, 1 over 9, 2 over 7, 5 over 11, and 21 over 22. And this is the order that we get. Okay, so that is how you use benchmarks. That's all for this video, and that is all for this section.